Welcome to Eureka Math. I'm Mr. Schenkel. This is 8th grade, Module 4, Lesson 6. Let's get started. Okay, our job today is to find the value of x that makes the equation true. We're going to use our algebra rules to make that happen, and you can see today we have some more complicated expressions on each side of the equal sign. So we're going to use our properties to simplify as much as possible before we go ahead and isolate the variable. So let's get that going here on number one. First thing I see is that we can use the distributive property. Let me get my pen working. Right here. Now, you might think, well, this is just 5, but I want you to think of the sign in front of that constant as belonging to that constant, and then use that in our calculation. So in this case, we would have 17. And then a negative 5 times a positive 2 is a negative 10x. And then we have the next distributive of negative 5 times negative 9, which is a positive 45. That way we can get the proper the proper symbol in front of each integer. Okay, and that's the left side for now. Let's go over to the right side, and this negative outside of the parentheses still needs to be distributed. We can think of this as a negative 1. So this is negative 1 times negative 6. That's a positive 6x. And then a negative 1 times 10. That's a negative 10. And then we have a constant of a positive 4. Okay, moving back to the left side again, we can combine some like terms. So I have a constant positive 17. I have another constant positive 45. Put those together, we get 62. So negative 10x and a positive 62 is equal to, on the right side, I have a negative 10 constant and a positive 4 constant. Put those together, and we get 6x minus 6. A negative 10 and a positive 4 is a negative 6. Okay, and then we can work on getting the variables all on one side. So I have a choice here. I can move the 10x to the right side, or I can move the 6x to the left side. If I move the 6x to the left side, I'm still going to have a negative x. I like positive coefficients, so let's do that. Let's take this negative 10x and undo that with addition, balance the equation, and then we're left with, this goes away, we get 62 is equal to 16x minus 6. Now we've got all of our variables on one side, and we can start to isolate the variable. And we'll do that by undoing the subtraction with addition, add 6 to both sides. That gives us 68 is equal to 16x. And then finally, I'm going to multiply by reciprocal. You could divide by 16. I'm doing the same thing by multiplying by the reciprocal of 16. If you use this method, then when we get fractional coefficients, it's no change in how we solve this problem. So the 16 divided by 16 cancels. It becomes a 1 or 1x, which is what we want. And then finally, we just need to do 68 divided by 16, and that is 4.25. 4.25. And that's what x is. It's the one solution that makes this complicated equation true. All right? Number 2. Same idea. Simplify both expressions as much as possible. Get the variables on one side. Isolate the variable. So distributive property. Remember, this is a negative 1. Negative 1 times x is a negative x. And a negative 1 times negative 7 is a positive 7. Plus 5/3. Okay, and that's equal to distributive property again. 2 times x is 2x, and then 2 times 9 is a positive 18. Now we need the variables on the same side, so I am going to use, I'm going to move this negative x with a positive x, balance the equation. The x's go away, I get 7 plus 5/3. Well, I can do this now as well. It's really, if I change the 7 into something over 3, I can add these together easily. So I'm going to think of the 7 as 21/3. 21 divided by 3 is 7, plus 5/3, and then we'll simplify that in the next step. That'll make that addition much easier. And then left on the right side, we have 2x plus 1x is 3x plus 18. Okay, now I can add on the left side. So let's do that. 21/3 plus 5/3 is 26/3. And that's equal to 3x plus 18. But I'm going to have to move that 18 in order to isolate the variable. So I would like the 18 to also be written in terms of thirds. So if I multiply by 3 over 3, that's going to give me 18 times 3 is 54/3. So 18 is the same as 54/3. And now I can do the isolation. So I'm going to isolate that, start to isolate the x by subtracting 54/3 from both sides. And when we do that, this goes away, and we get 3x is equal to a negative 54 and a positive 26. If we put those together, we get a negative 28/3. Negative 28. Come on. Thirds. That's a 2. Negative 28/3 is equal to 3x. And then the last step will be to multiply by reciprocal of 3. So multiply by the reciprocal, which is 1/3. Multiply this side by 1/3. And the 3's go away. So I get x is equal to 1/3 times negative 28/3. Well, that's just multiplying fractions. Numerator times numerator gives me a negative 28 over 3 times 3 is 9. So x equals negative 28/9 is the value of x that makes that equation true. Next. Distributive property. So we're going to start with 4/9 plus 4 times x is 4x. And then a 4 times a negative 1 is a negative 4. And that's equal to, let's see, 28/9. And then this is a negative 1 that needs to be distributed. So that's a negative x, negative 1x or negative x. And then negative 1 times a negative 7 is a positive 7x. All right, and then plus 1. Okay, still a lot of combining to do. So I've got a couple of constants here that I can put together, 4/9 and a negative 4. I would like the negative 4 to be in terms of ninths. So 9 times 4 is 36. So this is negative 36/9. So let's just write this again. 4/9 plus 4x minus 36/9. A negative 36/9 is the same as negative 4, but now it's in terms of ninths, so I can combine the positive 4/9 and the negative 36/9 to get a negative 32/9. So we have 4x minus 32/9 on the left side. That's as simplified as I can get it. On the right side, I have some variables I can combine first, a negative 1x and a positive 7x. That's going to be a positive 6x. And then I've got 28/9 and a +1. Well, the +1 can be thought of as 9/9. Wow, come on, pen. 9/9. So 28/9 and 9 more 9s. That gives me 37/9, and it's positive. 37/9. All right, that's as simplified as I can get the right side. Now we're going to go about getting the variables on the same side. So 4x and a +6x, I'm going to subtract 4x from both sides. That gives me a +2 on the right side. The x's go away on the left side. I still have the -32/9 over there. On the right side, 6x minus 4x is 2x, and I still have the 37/9 on the right side. Okay? Next step, get rid of the, try to isolate the variables. So the first thing I'm going to do is undo addition by subtracting 37/9. My goodness, 37/9. And doing the same thing to the other side to balance the equation. That's a 37/9 as well. And when we do that, the 37/9 goes away on the right side. I'm left with 2x is equal to a -32/9 and a -37/9 is a -69/9. Let me write that over here. -69/9 is equal to 2x. I need some room. I'm going to make some space here over on this side so we can finish this equation because I ran out of room. All right. Here we go. -69/9 is equal to 2x. And then I'm going to multiply by reciprocal. Do that to both sides to balance the equation. And the 2's will cancel. I get x is equal to 1 times the -69 is -69, and 2 times 9 is 18. So that's my answer. X is -69/18. That was a long one. Number 4. Distributive property. Should be getting the hang of this. 5 times 3x is 15x. And then a 5 times a +4, that's a +20. Minus 2x. Equals, on the right side, 7x. Then we have a -3 times a -2x, that's a +6x. And then we have a -3 times a +11, that's a -33. Okay? Combine like terms. Okay, on the left side, I have a +15x and a -2x. That's going to be a +13x plus 20. Equals, on the right side, I have a +7x and a +6x. That is a 13x minus 33. Next step, get the variables on the same side. Well, I have 13x positive on both sides. I'm going to subtract 13x from the left side. I'm going to balance the equation by subtracting 13x on the right side. And when I do that, those 13x's go away. I'm left with 20 equals these 13x's go away, and I'm left with -33. And so what is x? 20 equals -33? No, it doesn't. It does not equal -33. So in this case, when this happens, this means that there is no solution to this equation. There is no value of x that will be the same, that will be a solution to this equation. There is no solution. So I'm just going to write no solution. All right? When you've done these enough, you'll be able to recognize that right here in this step, where I see 13x on one side, the same 13x on the other side. They are going to eliminate each other, and that just leaves 20 equals -33, and that's not true. So no solution. Number 5. Here we go again. All right, let's see. 7x. Come on, pen. This is a -1, remember? -1 times 3x is a -3x. Wow, my pen is just really not happening. -1 times 5 is a -5. And then we also have this -8 that's not included in the distributive property. It's not inside the parentheses, so we just list it. Equals 1/2 times 8x. That's 8 halves x, and 8 divided by 2 is 4x. 1/2 times a positive 20, that's 20 halves. 20 divided by 2 is 10. That's a positive 10. And then we have a -7x and a positive 5 not involved in the distributive property. Okay, next we're going to combine like terms. Let's see, on the left side I have a positive 7x and a -3x. That's 4x. All right, and then I have a couple of constants here, a -5 and a -8. Put those together, that's a -13. Is equal to, on the right side, I see a positive 4x and a -7x. That is a -3x. And then I see a positive 10 and a positive 5 that can go together. That's a positive 15. All right, now we're down to moving the variables to one side or the other. I'm going to do that by adding 3x to the right side, adding 3x to the left side, and that gives me 7x minus 13 is equal to, the x's go away, 15. Now we can isolate the variable, add 13 to undo the subtracting of 13, balance the equation by doing the same thing to the other side. The 13's go away. I'm left with 7x equals 15 plus 13 is 28. And you may think, well, I'll just divide by 7. You can certainly do that. I'm going to multiply by reciprocal just to keep in that habit. 7's go away. I get x equals 28 divided by 7 is 4. X equals 4 is the only value of x that will make this equation true. All right, and last one. Write at least 3 equations that have no solution. So remember from a couple of questions ago, as long as the equations end up with the same number of x's on both sides and the constants are different, we're going to get no solution. So let's start with an easy one. 2x plus 1 is equal to 2x plus 2. That's no solution because, let me just show you if I tried to solve this. If I tried to solve this, come on, I would subtract 2x from the left side. I would subtract 2x from the right side. These x's go away, I get 1 is equal to, these x's go away, I get 2. And since 1 does not equal 2, no solution. So that's all we have to do is make an equation, make up an equation where the x's are exactly the same on both sides, and we'll get no solution. Let's try another one. Let's make it a little more complicated. How about 3x plus 2 minus 2x is equal to, let's go negative 9x plus 5 plus 10x. Okay, that's no solution because if I were to solve this, I would combine like terms. A positive 3x, a negative 2x gives me x plus 2 is equal to a negative 9x, and a positive 10x gives me x, 1x, plus 5. And as soon as I could see that my x's have the exact same coefficient, in this case 1, all I'm going to be left with is 2 is equal to 5, and that's not true, so it's no solution. Right? We could go on and do this forever. Let's make a nice simple one. X minus 5 equals x plus 7. There's my third one. Negative 5 does not equal 7, so I know it's a no solution. There it is. That is lesson 6. Hope that helps. See you again next time.